Welcome to JMeter Academy lesson number 4, Config Elements, Scoping, Execution Order, and Logging. Let's have a look at today's agenda. So we're going to cover JMeter configuration elements, which really is the last of the basic building blocks in JMeter that we're going to cover. And then we're going to move on to helping you understand exactly how JMeter sort of interprets your test plan. So how does scoping rules work? How does setting a value in one place versus another affect your test plan? And then execution order, which is literally how does JMeter step through your test plan and how do things flow? And then we'll wrap up by looking at JMeter logs. Let's get started with the config elements portion of the test plan. In this part of the lesson, we're going to discuss such elements as HTTP request defaults, HTTP header manager, HTTP cache manager, HTTP cookie manager, HTTP authorization manager, and DNS cache manager. Let's start a new test plan and start with HTTP request defaults. HTTP request defaults set the default values that HTTP servers use. The main goal of using the HTTP request default config element is to avoid data duplication in tests and make test plans easily maintainable. Let's make a simple demo test plan. Let's add HTTP request default config element to the test plan. And in the server name field of the HTTP request default, let's enter the URL of the BlazeMeter demo site, blazedemo.com. Then let's select the implementation of the HTTP request sampler, HTTP client 4. Then I add a thread group. Under the thread group, let's add some HTTP samplers that navigate to the blazedemo.com site. But note that we won't put the server name of the HTTP requests, we'll leave it empty, since we've already defined this value in the HTTP request defaults configuration element, right? So instead of putting in the whole address there, here's where we defined it, yeah? Let's add that second sampler here. There we go, HTTP sampler. So in this one, we're going to go a different path, but still on that same server. So let's go ahead and type in that URL. I'm going to go to vacation for this one. Then let's add a view results tree listener to our test plan. And save our test plan and run it. And have a look. Now we can see that we went to the blazedemo.com site and then we went to the blazedemo.com site vacation. So the full URL gets assembled, but it's built up of the component up here in the defaults, plus just the paths we gave in each of those requests. The next configuration element is the HTTP header manager. HTTP header manager adds or overrides HTTP request headers. Let's add this configuration element to our demo test plan. Now for readability, I'll move it back up here to the top. Okay, good. The HTTP header manager specifies a list of HTTP headers that will be added to the HTTP samplers of the JMeter test plan. Headers will be added to those samplers that are in the scope of the HTTP header manager. We'll talk about scope in the JMeter components a bit later. Let's add an entry to the HTTP header manager. Click on the Add button, and for example, let's add an accept language header. And as a value, let's specify Portuguese and English language. This HTTP header will be added to all HTTP samplers that are in the scope of this header manager. If this particular header has been already defined somewhere else in the test plan before this HTTP header manager, then this value will override that one that has been previously defined. Let's save the test plan, launch the test plan, and check the execution result. We can see that the specified accept language header has been added to the HTTP request. The next item on our list is the HTTP cache manager. HTTP cache manager is used to add caching functionality to HTTP requests within its scope to simulate the browser cache feature. Let's add the HTTP cache manager to the test plan. Again, for readability, I'll drag it up here. By default, the Cache Manager will store up to 5,000 items in the cache per each virtual user thread. There are two more options in the HTTP Cache Manager dialog. They are Clear Cache each iteration and Use Cache Control Expires header when processing the GET requests. If the first option is checked, then the cache is cleared at the start of the thread. If the second option is selected, then the cache control expires value is checked against the current time. If the request is a GET request and the timestamp is in the future, then the sampler returns immediately without requesting the URL from the remote server. And as a result, the response is returned from the cache with a much shorter response time. The next configuration element is the HTTP Cookie Manager. Let's open a demo test plan for the demonstration. HTTP Cookie Manager stores and sends cookies like a web browser. If you have some HTTP request and its response contains a cookie, the Cookie Manager automatically stores that cookie and will use it for all future requests to that particular website. Each JMeter thread has its own cookie storage area, so if you are testing a website that uses a cookie for storing session information, each JMeter thread will have its own session. Note that such cookies do not appear in the Cookie Manager display, but they can be seen using the View Results tree listener. Let's launch a demo test plan and see how the cookies are passed. We can see that the response of the first HTTP request contains a PHP session ID cookie that is sent from the server, and that the following HTTP requests contain exactly the same cookie. Let's disable the HTTP Cookie Manager, launch the test plan again, and see what happens. Clear our results here, run it again. Now we can see that in each response, the PHP session response cookie is sent, but since the HTTP Cookie Manager is disabled, the cookie is not stored in JMeter and no cookie is sent in the subsequent HTTP requests. So we see that the cookie keeps being sent, but if we go and look in here, it's not being sent back from the client. So we get the cookie from the server, but since we don't have a Cache Manager, we're actually not sending it back, which is why that HTTP request failed there. Let's open the HTTP Cookie Manager and see what is there. Here we can see that we can select the cookie implementation and cookie policy, and with this checkbox here, we can control if cookies are cleared after each iteration. It's possible to manually add a cookie to the Cookie Manager. You would just click on the Add button, specify the name of the cookie, its value, its domain, its path, and if the cookie is secure or not. Bear in mind, however, that if you add the cookie this way, the cookie will be shared by all JMeter threads. Note that such cookies are created with an expiration time far in the future. The next configuration element we are going to discuss is the HTTP Authorization Manager. HTTP Authorization Manager is used when we need to access a restricted page. It specifies one or more user logins to web pages that are restricted to using server authentication. We can see this style of authentication when we attempt to access a restricted page and the browser displays a login dialog box. Let's add this config element to our demo test plan, and then we'll discuss what's in it. The HTTP Authorization Manager keeps the list of URLs of servers that require basic digest server authentication and appropriate usernames and passwords for them. In order to add an entry to this table, click on the Add button and fill in the URL, username, password, select authentication mechanism, and if it's NTLM authentication, you need to fill in the domain and realm fields. After this table is configured, every time JMeter gets a request from the tested server for basic type of authentication, it looks up the server URL on the table, picks up the username and password from the found record, and passes them to the server and gets authenticated. The last configuration element we're going to discuss today is the DNS Cache Manager. This configuration element is used if we need to write a test for web services deployed on a few servers when a load balancer is used, or when we're going to test a CDN, a Content Delivery Network system. Without DNS Cache Manager, we risk sending the request to only one server of the system, overloading it, and getting an incorrect load testing result. The DNS Cache Manager helps to resolve this issue. Let's add the DNS Cache Manager to the test plan and investigate it. Right-click on the test plan, add config element, DNS Cache Manager. In this configuration screen, we can see some options and two tables. In the options area, we define what DNS resolver we are going to use for our tests, the operating system's DNS resolver or custom DNS resolver. If System DNS Resolver is selected, then DNS Cache Manager will query DNS servers defined in our operating system's network configuration in order to determine the IP address of each hostname. If we define Custom DNS Resolver, then the DNS Cache Manager will query that. Just click on the Add button and add a hostname or IP address of that custom DNS resolver. If more than one server is provided, then DNS Cache Manager will choose one randomly for each call. The second table is the static host table. The static host table and the static host feature were introduced in Apache JMeter version 3.2. This feature lets us make our own DNS table and choose which target server we want to test. This allows us to specify hosts for our custom DNS resolver, which maps the server domain we are testing to the IP or host name we are trying to reach. In other words, if we have some server named www.example.com and we want to reach it through the IP of a server, for example, other.example.ru, then we add the corresponding record to the static DNS table. In order to add a record to the table, we need to select the Use Custom DNS Resolver option first. Then we click on the Add Static Host button of the static host table, enter host name, and add another host name or IP address. So over here we type in www.example.com. That's the URL that actually is in our test plan. And over here we write the host name we want the traffic to go to instead, other.example.ru. We could put an IP address here as well, but one cool feature is if I have another actual DNS address, I can just use both DNS entries and not have an IP address here. After that, if we use www.example.com in your HTTP samplers, the request will be made against the other.example.ru instead, but with all the headers still set to www.example.com. Let's move on to scoping rules. Scoping rules define the scope of application of JMeter assertions, timers, configuration elements, listeners, preprocessors, postprocessors, depending on the position in the test plan. To continue, let's open a JMeter test plan that contains a skeleton with all the JMeter components in it. I'll expand this and then let's have a little conversation about what's going on here. First of all, samplers and logic controllers are like statements and operators in a programming language. Their scope is the exact point in the test plan where they're defined, and they can be added only under a thread group. But other JMeter components can be added anywhere in the test plan. JMeter assertions, timers, listeners, preprocessors, postprocessor components have the scope dependent on where they are placed in the test plan. If they are placed at the top level of the test plan before thread groups, they'll impact all samplers and logic controllers of the entire test plan. For example, this constant timer impacts all samplers of the test plan. And this view results tree listener here reports on information on all executed samplers in the entire test plan. If they're placed under a thread group, they impact all samplers and logic controllers of that particular thread group. For example, in thread group 2, the constant throughput timer impacts only the HTTP request samplers of thread group 2. And the user parameters preprocessor sets user parameters only for the HTTP request samplers of thread group 2. And if we look down here at the size assertion, we'll see that that only affects the samples made in thread group 2 as well. And in thread group 1, the aggregate report builds a report only for samplers of thread group 1. Now, if JMeter listeners or timers, assertions, preprocessors, postprocessors are placed under some logic controller that itself contains a group of samplers, for example, a simple, random, interleave, throughput, random order controllers, then these components impact only the samplers of that controller. For example, this uniform random timer only affects the samples of these 3 HTTP requests under the random order controller. And this JSR 223 postprocessor only processes the results of the same 3 HTTP requests under that random order controller that it's nested in. Another example for you here. This preprocessor, this regex user parameters preprocessor, only sets the user parameters for just these 3 samples. If timers, listeners, assertions, preprocessors, postprocessors are the child element of some sampler, just one sampler, then they impact only that particular sampler. For example, this JSR223 only affects the HTTP request it's under, and this size assertion only checks the HTTP request that it's under. The same is true for configuration elements. For example, this HTTP request defaults configuration element defines default settings for all HTTP samplers of the test plan. But if we move this component under thread group 1, then it will define default settings only for HTTP request samplers of this thread group. And another example, variables of this component can be accessed only by samplers and logic controllers of this thread group 1. Be careful with managers. If there are two managers in the scope of a sampler, only one manager is used, but there is currently no way to specify which one is used. Be sure you have just one. Let's talk about execution order. The execution order for JMeter components is actually pretty logical. First, it evaluates configuration elements, followed by preprocessors and timers, then samplers are run, and then they are followed by postprocessors, assertions, and listeners. Execution order is closely connected to scoping rules. Scoping is key, not the order of appearance from top to bottom. Only samplers and logic controllers are executed in the order of their appearance in the test plan. Other components may be declared in different parts of the test plan, but will be executed in the order we just mentioned, depending on where they are in the test plan and what scope they have. Let's turn our attention to the demo test plan. These configuration elements, the three managers, the HTTP request defaults configuration element and constant timer, these will be initialized before the execution of any sampler or logical controller in the test plan. Going one level down, these user-defined variables and random variables configuration elements, they will be initialized before the execution of any logical controller or HTTP request sampler in this particular thread group. Logical controllers and samplers under them will be executed in the order of their declaration. But this constant timer, it will be initialized before the execution of this HTTP request sampler, but after the execution of the samplers under this simple controller. This uniform random timer will be initialized before the execution of these three requests under the random order controller. And the JSR223 postprocessor will happen, of course, after each of the three requests under the same random order controller. And this response assertion here will be executed after each of the two requests within this critical section controller. It doesn't matter whether it's declared here or if we move it up here. It'll have the same effect. Down here at the bottom of thread group 1, we see the aggregate report listener. It will consolidate execution results of every sampler in this thread group, and it will update the aggregate report table after execution of each sampler. That's all we have about scoping rules and execution order. Now let's move on to the final part of our lesson. Let's talk about logging. JMeter provides logging of every action and every event while it's working. A log file can be helpful in determining the cause of errors. It's particularly useful to see log messages when debugging dynamic scripting languages like Bean Shell or Groovy. The latest version of the Apache JMeter logging system uses the log4j logging framework. The JMeter log levels are types of severity for messages that are written in the log. They are based on the log4j framework log events. They are none, error, warn, info, and debug. To continue our investigation of logs, let's create a simple test plan. We'll add a thread group, and under the thread group we'll add a dummy sampler. And a view results tree listener. And we save the test plan. And launch the test plan. The test plan has been executed. Now let's find the Apache JMeter log file and check what has been written there. The Apache JMeter log file is located in the installation directory of JMeter in the bin subfolder. The file name is jmeter.log. Let's open it. It has records in it, Each record has its own log level, for example, warn or info, as we can see here. The control of logging is done in the log4j2.xml file. This file defines the file name of the log file, format of log records, and log levels for different log categories, for example, protocols, JMeter engine, graphical user interface, etc. Let's get back to JMeter. There's another way to view the JMeter log from the JMeter environment. Just open the Options menu and check Log Viewer. Below, you can see the JMeter log. Click on this entry again, and the view of the log closes. You can also click the icon with the exclamation point and the yellow triangle right here to toggle the log open and closed. And the number to the left of that icon indicates the number of errors and will actually increment as errors occur. As of version 3.2, the log level can be easily changed for any element of the test plan. For example, let's change the log level for the root of this test plan. I'll click on the test plan, navigate to the Options menu, select log level, and change it to warning. Making this change means that only warnings and errors will be output to the log. Let's open the log viewer. In the log viewer, we see a notification that we have changed the log level to warn. Let's launch the test plan. So the test plan is run, but there are no messages in the log because no errors occurred. Let's change the log level back to the debug level. Now let's launch the test plan. And we can see the log messages now appear in the log. The log level for specific categories of the root logger can be overridden directly on the command line when JMeter is launched, and the log file name can be changed as well by passing a new log file name in the command line. JMeter has functions that can be used to print out information into the log. Let's check out how these functions work by calling them from the dummy sampler. First, I'll open the Options Function Helper dialog. I'm going to locate these functions. They are log and log n. Here we are, log and log n. Let's use the log function. Into the first parameter, I define the string that I want to print out to the log. For example, let's type some log message. Into the second parameter, I define the log level. Let's set it to be error. Then I generate the function code, copy and paste it into the response field of the dummy sampler. Then I save the test plan and launch it. Let's look into the log. Here we can see an error message, the one we printed out using the log function. Notice also that the error count is increased by 1 because we printed out an error in the log. That's about it for JMeter logs. Okay, well that wraps it up for this session. Just to recap what we did, we talked about JMeter configuration elements. We then moved on to really understanding kind of how does JMeter sort of parse and piece together and flow through a test plan, and that's where we talked about scoping rules and execution order. And those are super important concepts. Once you have those grasped, you have a lot of power at your hands. Without understanding those, you may see mysterious behavior you don't really understand. And then finally, JMeter logs, which is a way to keep tabs on what's going on and a place that you can write output to if you want to do some debugging that way. Thanks for joining us. We look forward to having you in the next session.